Welcome to ETE MCQs. Now let us solve a problem. It's a NPTEL problem asked in discrete time signal processing course. Find the impulse response of the overall system as shown in figure, where h of 1 is equal to beta into del of n minus 2 and h2 of n is equal to alpha power n into del of n minus 3. So you have an interconnection of system as shown in the figure, where h1 of n and h2 of n are given, and any one of the four options will be your final solution. Now, if there is a direct interconnect or direct link between the input and the adder, this should be taken as del of n. This should be taken as del of n. This should be taken as del of n. Okay, now this is the overall interconnection of systems we have. Let us assume that h of n is the overall impulse response. Okay, so if h of n, let h of n be the overall impulse response. So if that is the case, we will have h of n is equal to, you can notice that these two, this path and this path are both are in feed forward path. So I can just take the first system to be sum of del of n plus h1 of n. Del of n plus h1 of n. So this is the first subsystem we have, which is nothing but sum of del of n and h1 of n. This part is in cascade or it is in series with h2 of n. So when two systems are in series, we make use of the convolution operator to find the overall impulse response. So here you will have h2 of n. Okay. Now what we can do is, based on distributive property, this can be further rewritten as del of n convolved with h2 of n plus h1 of n convolved with h2 of n. This is all what we have. And we already know that based on the property of unit impulse function, any signal when convolved with unit impulse function will just lead to the same signal. Okay, based on the identity x of n convolved with del of n is equal to x of n. So based on that, the result of this convolution will be h2 of n. h2 of n. And here it is plus h1 of n convolved with h2 of n. So this is all we have. Now what is the overall h of n? H of n can be, let us just write it in terms of the right hand sides we have. We will have h of n is equal to, what is h2 of n? h2 of n is alpha power n into del of n minus 3 and plus h1 of n is nothing but beta into del of n minus 2. This is convolved with h2 of n. Convolved with, what is h2 of n? h2 of n is nothing but alpha power n into del of n minus 3. This is all we have. Now further, the above expression can be rewritten as del of n, alpha power, the above expression is rewritten as alpha power n into del of n minus 3 plus Let me multiply the constants together. I'll have alpha power n into beta, and then you have a convolution between del of n minus 2 convolved with del of n minus 3. Okay, we already know that convolution of two delayed version of unit impulse function will yield the overall delay in the convolution result. So we will have alpha power n into del of n minus 3 plus alpha power n into beta. Convolution of these two will be the overall delay, or the sum of the time indices will get you the difference between the time indices will get you the overall convolution result. It is nothing but del of n minus 5. Okay, the same answer can also be obtained using Z transform. Okay, so you should be getting this alpha power n into del of n minus 3 plus alpha power n beta into del of n minus 5. So the final solution should be A. A should be the final solution. Now let us try to solve the same problem using Z transform. Okay, a slight change. Just to verify, you can just relate it to Z transform. So to verify the result using Z transform, let us just take this as equation number 1. Taking Z transform on 1, taking Z transform on 1, h of n on taking Z transform produces h of z, which is equal to alpha power n is a constant, you can just keep it as such. Del of n minus 3, we already know that Z transform of x of n minus k is equal to z power minus k into capital X of z. This is your time shifting property. Based on time shifting property, this is what we have. If you just apply it over here, we know that Z transform of del of n is equal to 1. We know this. You just apply it over here. Now del of n is delayed by 3 samples. So you will have z power minus 3 into 1. Z power minus 3 into 1 plus beta and alpha power n and beta can be taken constant, can be taken as a product, alpha power n into beta, and then you take Z transform on del of n minus 2, you will get, based on time shifting property, it is z power minus 2 into del of n. Z transform on del of n is 1, and convolution altogether will be replaced by multiplication. So you will have a multiplication. Alpha is taken already outside. So Z transform of del of n minus 3 is z power minus 3 into 1. Now further this can be rewritten as alpha power n into z power alpha power n into z power minus 3 plus alpha power n beta, the whole into z power minus 2 into z power minus 3 is z power minus 5. This is all we have finally. Now you can take inverse Z transform in order to find the time domain impulse response. Now taking inverse Z transform, taking inverse Z transform, h of z on taking inverse Z transform produces h of n, which is equal to constant is alpha power n, and the inverse Z transform of z power minus 3 is del of n minus 3 plus the second term is alpha power n into beta. Alpha power n into beta. Inverse Z transform of z power minus 5 is del of n minus 5. So you get the Same solution actually. Alpha power n into del of n minus 3 plus alpha power n beta into del of n minus 5. So option A is correct. Is the correct solution. Option A is the correct solution. This is one way to verify. Just whenever you solve a problem, see to that you just verify it in by a different method so that you ensure that your answer is correct. It will get you a better understanding. Okay. Thank you.